Look at that. 394 subscribers. I got one in the last 28 days. Man, I won't have to do my regular job soon. I'll be independently wealthy. Any day now. All right. Today we are looking at the MidChapter quiz. Yeah. Hold on, give me a second. Yikes. Don't know what's going on. Okay, here we go. Let's delete all that stuff. Okay, so MidChapter quiz. I'm like roughly looked at it. I mean, I went through it thoroughly one time before I make the video. I would never just one shot something because, you know, that's where you make mistakes. Bro.
Oh, sorry. Oh, it smells pretty good.
Anyways, let's get started.
Smell it. It smells good.
No, dude, get out of here.
Hey, that's the math that I'm doing right now.
I know.
Right now.
I know. So, like, in Algebra 2...
It's the exact same thing.
a little bit. But you can't do these quickly. Like, how would you do number 1?
I would probably go... What's that movie coming from?
I'm not going to worry about it. All right, get out of here.
Actually, I have no idea what I would do.
Oh, my God. So, I do know how to do it, but you don't know how to do it. Have you heard, does your teacher teach counseling? Like you cancel terms out?
No.
Or does she teach the identity property of multiplication?
I don't know what any of that means.
Oh, my God, bro.
Shop like a billionaire.
Dude, get out of here, please.
Wait, what is this?
Don't worry about it.
Okay.
All right, so.
Can you guys have some pasta?
Yeah, go ahead.
So, can you call the school and tell them that I can sub Girl Scout cookies?
Oh, my God. We'll talk about it later.
Okay.
All right, get out of here.
Okay, bye-bye.
Can you close the door?
Why?
Please.
You don't want to be my bestie?
Just close the door, please.
Bruh.
Okay. Using the commutative property.
Oh, I know what that is.
And the associative
I know what
property.
that is too.
I'm going to change things around. There's one like kind of big principle that comes with fractions. Is that like if I had 2 over 3 times, I don't know, 4 over 7, I can write this as 2 times 4 divided by 3 times 7. Or if I started with this, I could break it up into partial fractions. Doing that, I'm going to get all the x's together, all the y's together, and things that look like familiar. So I'm going to do 14 and 7. Those look like good numbers to group with. Times, I'm going to do this 2 and the 18. Those look good numbers to group with. I'm going to group all the x's. So x squared times x over x cubed times x to the 4th. All the x's. I'm going to group all the y's together. Their own little partial fraction. Y times y. Boom, 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 boom. Okay, and then I'm going to do the z's together. So I get a z squared over z. Like I'm allowed to do this as like commutative property and associative property and how fractions work. I can kind of break them up, move them around to my leisure. All right, what's this going to reduce down to? This is 2 over 1. What's this going to reduce down to? 1 over 9. What's this going to reduce down to? So we got x cubed on top. We have x to the 7th on bottom. If I did this right, you should get 1 over x to the 4th. Basically, like this one is going to eat those two guys. And then we look at the y's. You have y6 on top. If you have y squared on bottom, I believe this is y4th on top. And you'll have a 1. And then finally, you'll have z over 1. And now you can like take these partial fractions and make it a single fraction by multiplying. So we get 2 y to the 4th z all over 9x to the 4th. And there it is. Again, I don't know if I mentioned this, I'm not going to try to use the word canceling and use the identity property and reducing fractions and stuff like that. I think when we use canceling, like we just overuse it. All right, number 3. I get 3x minus 3 over, I'm going to go ahead and factor that bottom. That's x plus 2, x minus 1. I don't know why I didn't factor the top, but too late. I'm going to factor this top, 4 times x plus 2. I'm going to factor the bottom, 6 times x plus 3. If I did that right, looks good to me. Looks good to me. I'm going to continue factoring 3x minus 1. And I'm going to rewrite this fraction here as 3x minus 1 over x minus 1 times 1 over x plus 2 times, or if I want, I could take this x plus 2 and put over this x plus 2, and then I'll have 4 over 6. This is like really unorganized. And then finally, a 1 over x plus 3. Wow, that's really unorganized. All right, this will reduce. This will be 3. These x plus 2s will turn into 1. This will turn into 2/3. Am I doing this right? Sure. Times 1 over x plus 1, x plus 3. Now these are all fractions, so you just multiply the numerators together, multiply the denominators. In multiplying the numerators and denominators, those 3's will reduce. So we'll get 2 over x plus 3 is my answer. Not bad. On to the next. I'm feeling like pretty okay with this unit. Like I don't see there's like a really big hurdle. Yeah, I know there's like those graphing days, but then you practice at that, it's not bad. And given a unit, there's always gonna be like one really challenging thing. Let's see, r times r plus 3. I mean, I guess fractions in general are challenging. R plus 1. And I'm going to rewrite the division as divided by 3r over 3r plus 1. Okay, when we divide fractions, we'll multiply by its reciprocal. So I get r times r plus 3 over r plus 1 times. These 3's will go away. They will reduce. And I'm going to multiply by the reciprocal. So r plus 1 and r. And then again, I can rewrite these fractions as r over r times r plus 1 over r plus 1 times r plus 3 over 1. Okay. These will reduce down to 1. This will reduce down to 1. So it'll be like 1 times that, which is just r plus 3 as my answer. On to the next. I don't know if I'm making good time. My daughter like really slowed me down. That's my middle daughter. She's like my smartest kid, but like the worst student. She doesn't care if the teacher likes her or not. The other two are more like, oh, you want me to do 1,000 problems? I'll do 1,000 problems. All right, factoring at the top, r plus 4 times r plus 2. On the bottom, r minus 2, r plus 2. This is r plus 4 over r minus 2. These will reduce. And I don't know. Just a pick multiple choice. This looks like a B to me. Yep. Yeah, she's like our one kid that's like not going to attend college. Like it won't make sense. But she'll be fine. She'll be like run her own business. I have 2 older brothers, and one's like a graphic artist, works for like a really big company, makes lots of money. I'm a teacher. Wait, a tutor. Very happy with my situation. I don't work a lot, so it's kind of nice. And then my eldest brother owns his own business, and in terms of careers, he seems the most happy. So I think like she's gonna like run her own business. All right, least common multiple. I'm gonna factor this. So we got x minus 1. I want to rewrite this as negative 3x plus 3, and then I'm going to factor out a negative 1. So you get negative 3, and then you'll get x minus 1. And so we want the least common multiple. Least common multiple. So these are factors, if that makes sense. So both of them have an x minus 1, so we only need one x minus 1. This guy's missing a negative 3, so we need a times negative 3. And this guy's missing an x, so we need a times x. But this is your least common multiple. Similar to like the least common denominator, it's the same thing. All right, 11. On to 11. Feeling good about this. Let's shoot for under 20 minutes. It would be nice. Let's see, 2 over 3m n squared minus 4 over n. Okay, so the least common multiple or least common denominator is 12m n squared. Okay, so what's my first term missing? Again, I can only have fractions if they have the same denominator. So I'm missing a 3n squared. So I'm going to multiply the top and the bottom. Again, our least common denominator is 12m n squared. And then we want to multiply the denominator to get to this. So what's this guy missing? Well, it's missing a 3n squared. So I'll multiply the top and the bottom. When I multiply the top, I'll get 9n squared. When I multiply the bottom, I'll get my 12m n squared, which is what I want for the bottom. The next problem, or the next fraction, it's just missing a 4 to get 12m n squared. So I'll say 8 over 12m n squared minus, the last one's missing a 12, an m, and an n. So it's like 48, an m, and an n over 12m n squared. So just one more time. This was missing a 12, an m, and an n. So I multiply 4 times 12, which is 48, and an m and an n. This doesn't seem very interesting because like it doesn't feel like anything reduces, but I can write this as a single fraction, which I think they want us to do. 9n squared plus 8 minus 48 mn, all over the least common denominator. Done. On to the next. 13. Let's see. I think I want to factor. I'm going to factor out a 3 first. X plus 2 over x plus y. And I don't know if this is obvious, but you want to factor out a negative. So, and this is going to sound weird, but I'm going to factor out a negative from the bottom and move to the top. So it's like negative x plus y. And the reason I'm allowed to do that, I'm going to do some side work, and then I'll erase it. I had this. And then I'm going to factor out a negative. And then I'll multiply the top by negative 1 over negative 1. And so this becomes negative 6 on top. And on the bottom is x plus y. Now you're like, well, why'd you do that, though? Well, I want the same denominator. I don't want to have multiply by stuff. Like, if I could do it without multiplying by stuff, it makes my job a lot easier, a lot easier. So now look at, they have the same denominator. So we can add the two fractions, keep the denominator, add the numerators. At the same time, I'm going to have to distribute this, even though I just factored it. So I get 3x plus 6 minus 6 all over x plus y. And the 6's cancel out and get 3x over x plus y. And those x's do not cancel out. Not at all. You'll violate order of operations. This is a grouping symbol. Can't just go in there. Cancel x. It has to be some factored form. Like if you had this, then yes. But you don't. That's all we have. On to the next. 15. Easy enough. Determine the perimeter of the rectangle. I don't know how you were taught. You know, you have this. And we now down here, 6 minus 6 over x minus 3. And over here is 3 over x plus 1. Because of parallel lines, this also has to be 3 over x plus 1. Or the definition of a rectangle, this also has to be 6 x minus 3. And then perimeter is just like going all the way around and adding it up. So I'm going to like shortcut it because we really have 2 times 6 over x minus 3. We have 2 of those. Plus we have 2 times 3 over x plus 1. This is 12 over x minus 3 plus 6 over x plus 1. All right, find the least common denominator. The first term is missing an x plus 1. The second term is missing an x minus 3. So go ahead and throw them on there. So I get 12 times x plus 1 plus 6 times x minus 3 over x minus 3, x plus 1. Distribute, combine like terms. Never FOIL at the bottoms. You always want to keep those factored. So we'll say 12x plus 12. Like you'll see, like as you go to higher classes, like you never FOIL out. Like you're always solving by factoring. This is better. Foiling is like you'll make a ton of mistakes. Which is like very counterintuitive, but like factoring is like will become easier as the problems get harder. All right, so I get 18x minus 6 over x minus 3, x plus 1. Like I want to factor out the 6, but it's not going to help me. It's not going to like, I guess it's a good habit, but nothing's going to reduce. Is what it is. It'd be cool if it was like 6x minus 18 and then stuff would have reduced, but it's not. On to the next. I feel like my textbook when I was a kid, like there's no videos, there's no like online stuff, there's no like written solutions. You just had the answer in the back, and it was always simplified. And for whatever reason, it always felt like it was 1. And I'd have just like crazy mess on my homework, and I'm like, how do I get this to 1? But different time. All right, 17. All right, so identify the asymptotes, main range. Okay, so it looks like you get an asymptote at possibly 3. -3, it's like a scale 2. So it's like -2, then -4. So yeah, let's just guess that x is equal to -3 as the vertical asymptote. And it looks like whether like the end behavior as x approaches infinity, the function values approaching 0, or as x approaches -infinity, the function value approaches 0. So I'm going to say our other horizontal asymptote is 0. Domain. Domain's going to be all real numbers except for x equals -3. You can't have -3. You'll divide by 0. Like they even gave you the function. Yeah, you can't. -3 bad. Range. If you look at the picture, it's like kind of obvious, but at the same time a little hard. It's like looks like this, and it looks like this. And if you look at the range values, the y values specifically, it looks like all the y values get hit except for 0. And I know there's like an argument of like, what about 0.1? What about that? But in theory, they're going to get like infinitely close to 0, but without touching. I think that's why we like interval notation. So like the range in interval notation would be like -infinity to 0, union 0 to infinity. Like you're excluding 0, but still getting really, really close. All right. Dude, I'm finishing this up. I was home for 20 minutes, but it doesn't matter. 19 f of x is equal to 4 over x. Okay, so this is like, you can graph this like how you've been graphing rationals. I don't really care with like intercepts and like plotting points and following intercepts. It's no big deal. But I think they want you to do it as, treat this as a parent function. And then you get like, my parent function looks like this. Has a vertical asymptote at 0 and a horizontal asymptote at 0 as well. This is the same thing. What's the 4 going to do? I mean, it's going to like stretch it vertically, make it go up faster, but it's really hard to see. So I'm just going to be like, it's like, I don't know. No. Let me see if I can see in Desmos. Yikes. Okay, it is. I got 1 over x, so this is my, it's not zoomed in. There we go. Oh, no more zooming. That looks pretty good. And then I'll do g of x is equal to 4 over x. It goes up faster. Don't know what to say. Vertical stretch. I don't know. It's like hard to see. It's hard to see. All right, on to the next one. 21. 21. So we got f of x is equal to 6 over x minus 1. Again, I probably use like transformation. So if this is my parent function, then this is going to shift to the right one. So my new function is going to look like, here's 1, and then we're going to be like, and there is always shifted 1 and vertically stretched by 6. 23. F of x is equal to 3 over x plus 2 minus 5. Same garbage, except for this is going to shift. So this is my parent function. We're going to take our parent function. We're going to shift it left 2 and down 5. And vertically stretch it, which I'm just going to say it was vertically stretched, even though it may not look like it. So move it twice to the left, and then shift it down 5. So 1, 2, 3, 4, 5. So my asymptote is going to change. There it is. So that's going to look like, yep. Look at that vertical stretch. And, yep. Yep. Looks good to me. Looks good to me. You can find that y-intercept. You let x equals 0. So if I let x equals 0, this is 3/2. Minus 5, which looks like that value, you know, drawn to scale. All right, on to the next. Sandwiches. Actually getting kind of hungry. Sandwiches. A group makes 45 sandwiches to take on a picnic. The number of sandwiches a person can eat depends on how many people go to the trip. What the what? 7.3. A group. So I'm assuming this is still like, you know, something over x. And we gotta find over something. A group makes 45 sandwiches to take on a picnic. The number of sandwiches a person can eat depends on how many people go. Write a function to represent the number of sandwiches that can be taken on a picnic. Why'd say ... Okay, a group makes 45 sandwiches to take to a picnic. Okay, so that's constant. The number of sandwiches a person can eat depends on how many people go. Okay, that makes sense to me. So this is like the number of sandwiches. That's like, no matter what, make 45. But how much each person can eat depends on the number of people that go. So if 9 people go, then we all get 5 sandwiches each. Okay, graph the function. I'm not going to graph it. What the heck? I don't even know what that means. I'm going to say 25 is a skip. Thank you, guys.